Hello and welcome to this section on modeling fuels in PLEXOS. This class provides a lot of flexibility to model the different types of fuels used in power systems. Fuel availability and limits, prices, and emissions associated with burning a fuel type are all aspects that can be modeled quite easily in PLEXOS. The first step would be to create an object in the fuel class. The class can be enabled in the config menu, if not enabled by default in the version of PLEXOS being used. With the object defined, it is important to create a membership between the fuels and the generators which use this fuel. The third step is to input values for properties such as price to define characteristics of the fuel. It should be noted that a single generator can use more than one type of fuel during operations. Using the generator.fuels ratio property, it is possible to input the amount of each type of fuel to be used by the generator. If the max ratio and min ratio properties are used, PLEXOS will optimize the amount of fuel of each type to be used with the objective of minimizing the total cost. A value for the generator.fuel transport charge property can be input if a cost is associated with transporting the fuel from its source to the location where it is used. This is an optional property and can be used in combination with some other properties such as tax, contract limits, or pipeline limits. Pipeline limits are relevant if using the gas module in PLEXOS. A fuel-specific heat rate can be defined using the generator.fuel heat rate property. Depending on the number of hours a generator has been offline since its last shutdown, the fuel offtake and hence cost when it is started back up can vary. The number of hours corresponding to a hot, warm, or cold start can be input using the concept of bands in PLEXOS in combination with the start cost time and start cost properties. Fuel price can be defined using the price and tax input properties. The actual value used in the optimization can be input using the shadow price incremental or shadow price incur, and shadow price scalar properties. If both price and shadow price are defined, then price will be used for accounting and will be shown in the output, while the shadow price input will be used for the actual optimization. Next, we will take a look at an example of defining fuel objects in the PLEXOS interface. You are welcome to pause the video at this point to try and complete this exercise. Note that this exercise will be referenced in multiple sections throughout the training series.